But thank you very, very much all for coming, and particularly to Rothamsted team and the other speakers here today for helping pull this together, which I hope will be a very, very insightful look at a landscape approach to carbon stocks in the soil. I'm not going to be doing too much talking, hopefully, today. There's too many experts to count, so I'll leave it to them. But I will do a very brief introduction. Apologies, my printer also broke this morning. I found my watch in it, thanks to my 4-year-old son. So I'm afraid I didn't manage to print out any of these copies, but I have dropped them into each of the slides, so we can keep on track, hopefully. So yes, we're going to be spending the morning running through what we've done over the last 6 months of sampling and analysis, and then looking at some of those results. I am going to say now that not all the results are on here. It's indicative at this stage. There's still a little bit more analysis or synthesizing. All the analysis has pretty much been done, but synthesizing those results and particularly uploading them onto the Land app software so that we can disseminate them with confidence to each farm. So apologies now that you're not all sitting with a beautifully presented document which has got all your results in it. That will be following soon, partly because we are dealing with some very new science and new technology, which Adrian will attest to, and I will, that we're the monkeys that didn't quite manage to make it work straight away. But thankfully, the guys at Rothamsted have got it all cracking. So that's the morning. We'll look at the results, and then in the afternoon, we're going to look at those next steps, and we're going to look at perspectives from the very new and nascent market as well. So it won't just be Rothamsted and myself. I represent Carbon Quester and the North East Scotswell Farm Cluster today. Carbon Quester being this new company that we're just setting up. So why are we here today? So the soil carbon market has been valued up to £750 million in today's money. Now that's quite optimistic at the moment, but there's every thought that could happen very soon and be valued much greater than that. The market is nascent, as I've mentioned, so that whilst there's a great opportunity, there's also some real challenges. There's challenges in the lack of data that's available in soil carbon at the moment. There's challenges in getting more of that data because it's very expensive, and I think we've all seen our fair share of snake oil in the market and used car salesmen knocking on your door, selling you this amazing carbon that's beneath your feet. So whilst there is an amazing market, it does need a little bit of cutting through to understand the true value and what there is and what there isn't available. And so that's what we set out to challenge with Rothamsted and their 170 years of academia generating some amazing results over in Harpenden, but also in the southwest as well. And then we partnered up with Stratton Parker Farms initially over in Essex, a 2,000 hectare trial across about 4 farms, all run by Stratton Parker Farms. And then Thames Water, when we're doing the sustainable farming piece for the Thames Water project, smarter water catchments, I wrote a carbon baselining trial into that, and that got the nod from them. Of course, the cluster, and with great thanks to Scott and Farming the Protected Landscape grant that we were enabled to pull together, and they've picked up the lion's share of that, the bill for this project. And then Land app as well. We are effectively developing this with them. They haven't invested nearly as much into any other kind of carbon projects like this. They've really been very helpful, particularly the last 24 hours. And what are we doing? So our solution is all in this novel data collection that we mentioned, and you're going to hear lots on that. That rapid assessment or cost-effective assessment to get some rigorous data that's backed up by a very effective sampling strategy as well, so that we're optimizing how many sampling points we take to get the rigor that we need. And of course, with Rothamsted, you've got the Roth-C model, so there's a lot of pedigree in there. But it's also got to be nuanced for each farm and scenario of food production versus other natural capital markets, and making sure that we're not just chasing carbon every time, but we are looking at the whole holistic picture. And productivity and feeding Britain, feeding the world is of course paramount importance. So this is the journey that we're taking. We start off with that novel data and collection and working out how we collect that data. Then we will be working out, once you've worked out your stocks, your carbon stocks, what the options are for the farm or the landscape. And then looking at how we might be modeling different scenarios and different interventions to build more carbon and look at other natural capital and yield productivity. And then further down the line, monetizing that. Carbon Quester at the moment not doing that ourselves, but as I say, we've got some perspectives from existing operatives in the room, so that'll be good. And then there's no good just coming up with all the science in year one without actually testing and verifying the uplift, and so repeat sampling down the line. And then machine learning our data sets to make sure that we enhance and make sure it's accurate going forward. What's our impact on climate change? Well, you're going to hear all about what we're doing in terms of sucking the carbon out of the atmosphere, carbon dioxide out of the atmosphere, using the plants to do that, putting it into the soil and leaving it there. Just as an indicative slide, but you're going to see lots more. This is one from our early trials, and you can see the 20-year of grassland next to an arable field, same soil types, same management up to that 20-year point. The difference in carbon is about 50 tons across different bands, different horizons, different amounts of carbon. But that's what we're going for. We are thinking, how can we increase this soil carbon in the ground? That's quite an extreme example. It's a land use change effectively from arable to grassland, but it does show what can be done in certain situations. And so that 50 tons of carbon in the ground is worth roughly 3.6 times in terms of CO2 equivalent, which is the factor that's bounded around in terms of trading tons of carbon. It's the carbon dioxide equivalent. So 50 tons times by 3.6 over the course of 20 years equates, by my maths, about 7 tons of CO2 equivalent per hectare per year. Trust me. But of course, it's not just about that. It's also about how we optimize land and optimize productivity through reductions of nitrogen and diesel, also increasing that soil health and climate change resilience. So whether that's creating a better sponge in that topsoil there so that we can retain more moisture to be more drought resilient, or to retain more rainfall to stop flooding, and of course all the biological activity as well as soil health improvements to help productivity. And those little symbols at the bottom of the Sustainable Development Goals aligning with the UN's SDGs there. So that is pretty much the background to why we're here. Going back to the agenda, we're now going to hear from Stephan. So this next bit's about the data collection. So John is going to introduce the sampling strategy, how we came to sample the. Oh no, sorry, beg your pardon. Stephan is going to introduce carbon sequestration, soil health, and soil organic carbon clay index. And then we go into how we approach data collection with stratified sampling and with the actual methods. So Stephan, over to the professionals.
Okay, good morning everybody. Yes, Stephan Haefele is my name. And I wanted to introduce you with me here. wanted to introduce the topic a little bit. I mean, Tim basically took half of it away already, but I'll show it anyway. If there is any questions or so, just ask in between, and that's fine. So yes, I wanted to basically address two things. One is carbon sequestration and soil health. What are the relations? Just a few slides on that. And the second one is on a soil health index, which we developed, which we actually think could be very useful also for this purpose, for projects like this. So when we talk about soil organic carbon, there's, again, Tim already said that, basically two main purposes. One is really about soil health, soil quality. So it helps to make the soils better. You can grow better crops. And it also supplies ecosystem services, right? Holds water better, recycles nutrients, these kind of things. And the other line is really about the global carbon cycle. There must be one more. Yeah. So overall, it's estimated that about twice as much carbon is located in soils as compared to the atmosphere. And of course, this is showing the importance of soils in two ways. One, you could then sequester carbon in soils, increase that amount, reduce the amount in the atmosphere. On the other hand, soils, of course, are also an important contributor. So when you convert forests to arable soils, you do contribute a lot of the carbon goes into the air. Another issue about the soil carbon is the emission of the greenhouse gases, here methane and N2O. That does have, again, an effect. So depending on the conditions, aerobic or anaerobic, you can emit methane. And also depending on the quality of the soils, you get higher emissions. So lower soils quality, compressed, you get higher emissions of greenhouse gases as compared to good soils. For soil health quality, basically, the organic carbon you add to the soil is basically the food for all the soil organisms, right? So essential, about 90% gets just broken down again, as I said, as food for the organisms, and helps overall, increases the year-to-yield stability because it helps to increase water retention. It reduces erosion. More water can enter the soil. Soil aggregates are more stable. Therefore, you have less water flow on the surface, contributing to erosion. You have the earthworms, which really use this organic matter, pull it down into the soil, again, use it as their food. So overall, that really contributes to a more sustainable system. Decreases also fertilizer need, right? Some of this organic material is then available, nutrients are available for the crop. So yes, that's a bit the good news on the whole story. So if you can increase soil organic carbon even by a little bit, that really goes a long way. So it does affect the properties, soil properties, even when it's hardly measurable. It already affects the soil properties. It doesn't necessarily mean that you get high yields immediately, but as I said, the ecosystem services do profit quite a bit. So here, this is just an example looking at quite a lot of straw return experiments by a colleague of us. And this is a bit on the other side. So Tim showed the positive example on the arable to pasture land. This is a bit more what happens on a farm. If you return straw to the soil, you do get an increase, you do get a positive effect in a lot of cases, but the change in soil, in the carbon concentration is actually not that big, right? Here, these examples, 1.8 to 1.9. So it increases by by 0.1% here in these examples. So that's so really, maybe it's wrong argument here, but you also have to be a bit careful. Yes, soil can store a lot of carbon, and there are definitely like the big changes going to pasture, going to forest or so, or agroforestry. There can be immense sequestration, but other methods you increase a little bit and slowly. It takes time, right? So that's also for the measurements. Usually, in most cases, you will need to wait 5 years to actually see a measurable increase. Also because, yes, the concentration in the soil is already quite high. So you increase by a little bit, you have measurement errors. So it takes a bit of time. Here, just an overview. I think John will give a bit more examples or give a bit numbers to this. So what kind of management options there are and which help. So yes, cover crops. There's also a recent study quite in Europe, quite a lot of sites. It does definitely help to increase soil organic carbon in the topsoil. Crop residues returned, we said already. Yes, there is the problem. You increase a little bit, but then there are other uses for straw, right? A lot of farmers sell straw, so you have to balance what you get out of it. Manure, of course, helps. Zero tillage helps. Although zero tillage, we don't really have the long-term studies yet, but very often it basically just shifts a little bit the concentration, increases in the topsoil, not much changes below, right? Then rotations, like better rotation systems. Again, we don't have so much data yet available, but there is some to show that this helps. And then, of course, there are the big methods is going from arable to grassland to ley systems, or even including trees. With that, I get to the second point, soil health index. So this again a little bit a repeat. So overall, we know that soil organic carbon is, of course, it's very positive in soils. And that's because it's basically positively related to a lot of good characteristics of the soil, right? Water holding capacity, structure here is pointed out. A lot of structure elements react positively to higher soil organic carbon contents. Recycling of nutrients, biological activity. So that's why we think soil organic carbon is a very important indicator of soil health. But first of all, there are quite a few factors which contribute to soil organic carbon content. So the soil moisture regime plays a role. The average annual temperature plays a role. Of course, use and management, we said that already. Soil reaction, pH affects the soil organic carbon. Chemical structure of soil organic carbon, that's a bit old school actually. Nowadays, we don't think it matters so much anymore. And then there is another big one, which is texture. So how much clay, how much sand, how much silt. And that is because most of the soil organic carbon is actually protected from mineral breakdown by linking to clay particles. So clay particles are the finest particles in the soil, smaller than 2 micron. So there would be these reddish parts. The big white thing is basically a sand grain, right? And that's where the soil organic carbon is protected in the soil and can then be stored. So,
sorry, were you saying clay? We're sitting on a lot of clay. Are you saying doesn't sequester carbon as well, or
no, the opposite. So basically, the more clay you have, the more soil organic carbon you can store in the soil, right?
Because it's smaller.
Because it's very small, so it has a very high surface area. So the organic compounds can bind to it. Even then, they are covered within the aggregates formed by clay, and therefore it's just not accessible to microbes for breakdown. Whereas if you have a sandy soil, yes, you have these big pores, as I said, these big white things are the sand, and there is full access to organic carbon for these microbes. So we knew that soil organic carbon is important, but because there are all these other factors, it's not something, it's difficult to compare a sandy soil with a clay soil, right? So we thought we come up with these index and looked in the literature. So basically the ratio is between soil organic carbon and clay. Yeah. So the graph here is on the x-axis is the percent clay in the soil, and on the y-axis is the only percent organic carbon. And basically this first study said, if the ratio between organic carbon and clay is 1 to 10, then you have all the clay saturated with organic carbon. So if you put more, you can do, but it's less protected. You're oversaturated. If you put less, you have free clay, which in theory could bind to organic carbon, but you don't have it there. Right? And then the second study went a bit further. So you again have the 1 to 10 line as the saturation. They said there is these other two lines, which are again, they are linked to structure, and they basically separate then very good soils above the yellow soils, above the yellow line, and the degraded soils in the blue line. Again, be a bit careful with degraded. This is degraded in the sense of soil organic carbon. Yeah, they are not necessarily bad soils, but with relation to carbon, they just hold less than they could. So, and then we had a look at how these how soils in England and Wales actually confirm with this index. To do that, we used the National Soil Inventory data. So England and Wales was sampled twice, one in the 70s, 80s, in a 5-kilometer raster. So every 5 kilometers there was a sample taken. And then a bit later again, around the 2000s, the sampling wasn't as dense. I think they took only 1 to 10 then. And from all these data points, we focus only on the agricultural use. So arable, lay, grass, and forest. And so all these points are the ones we used as data. And then we put basically the data onto these lines. And so first observation, so this is for woodland. You can see basically no data on the degraded line there. When you look at the numbers, so 2/3 are very good. About 5% are still what we call the degraded soils. Right? Second example, permanent grass. Pretty much similar picture, right? Few soils down here, 2/3 are above. Then you go to lay systems, and you see already there's a bit higher numbers below the line, and it goes down. So 15% are degraded, half of it are very good soils. And then you look at the last one, which is arable. Then you really see there's a lot of points below the lowest line and fewer are above. So in numbers, very good is about 28 and about 40% of all soils are in the degraded area. So, yes?
The lay grass.
Sorry again?
The lay grass. 2 years.
I mean, at the sampling time, basically the surveyors asked the farmer if that a lay system, it just changes every now from arable to a lay system. Yeah.
So I guess the key thing, Stephan, we should see that top left-hand panel as an opportunity, that there's lots of arable fields out there with lots of storage capacity that's not being used.
Yeah.
But there's still arable fields that are performing.
Yeah. Very often, this can also be the history of the field, right? So if for example, that field was only taken under cultivation 20 years ago, you would decrease your soil organic carbon, but not that fast. So we don't really, the data wasn't good enough to say, okay, that was the use at the time. We didn't know what happened before in detail. But then this is just comparison. So again, for the points where we had samples from both dates, right? This is the first survey, again, a bit different numbers because it's a smaller selection. And then the second sampling around 2000, woodland actually did improve a little bit, right? Did improve quite a bit. Permanent grass, the bad soils, the degraded soils remained the same, but the very good soils went a bit down, from 70 to 60%. Similar for the lay grass system, but you also can see that the arable system actually still degraded further, right? So, I mean, this is not new. I mean, arable farming as a whole since thousands of years does reduce the organic carbon in soils. It's just a fact. This is to show that, yes, of course, you can reverse this. So this is a long-term experiment at Woburn from which we run. And this runs since 1965 to now. The indexes are now horizontal lines because they are against the index. So you have the lower lines with 0.75 and then up and different treatments. So the fertilizer 1 and 2 are basically only inorganic fertilizer. And you see the lines stay even degrees further. Right? Then you have a system like the purple one, the lay, or the green lay plus nitrogen. Whenever the treatment is applied, the lines go up. Yeah, you improve the soils. You stop the treatment, it slowly decreases again. You apply again. So you can, based on your management, of course, you can affect your soil and you can get them out of this degraded area. And in this case, Woburn is quite a sandy soil. So even on a sandy soil, that's possible. I think this is actually quite important also for us here. This is that based on these studies, it's obvious that you cannot reach the same organic carbon level in the soil for all uses. They have different thresholds. Yeah, bringing up an arable soil to the level of a forest soil, it's possible, but you would have to put so much organic carbon that it doesn't really make sense. So we use this basically also as a target. So we say for agricultural soils, yeah, these down here are the ones where you have the real opportunity to improve them because they are also undersaturated with their clay percentage. So we say all the soils down here, you're pretty sure you can bring them up to the line. Yeah? And it also helps you to diagnose where you are. So you sample a field and you then know, yes, I'm actually in the green overall, or yes, I'm in the red and I can do something for this particular plot. Similar, we say lay arable, you can actually get to the 1 to 10 line. Yeah? All the soils which are below. And then for the woodland and permanent grass, we think you can get over the yellow line. And the data basically shows it. So, carbon sequestration also increases soil health. I mean, that's always also the long-term aspect, right? Even if there is payment for sequestering carbon, for the incentive in the long run might not be the carbon payments anymore when you reach a certain level, but the idea is then the incentive is you have healthier soils, which gives more stable crops. There's a range of management options, but a lot of them, the increase in soil carbon is slow, and it's not the jump from an arable soil to a pasture soil. For the index, we think it works across England and Wales. And it basically helps, it's all soils, so it's independent of soil type. We tested that. It's independent of climate, west versus east. So it's an index which really can help to evaluate the soils all over the place. Land use affects the index. We saw that a substantial portion of the arable soils are degraded, but the index helps you to identify where that is happening and you can reverse it. That's it. Are there